My name is Dan Dimler. This is the project proposal for Optimization Methods in Engineering, MEMS 5001. So our topic today is going to cover the knapsack problem optimization. The knapsack problem is basically a problem where you have a given, almost a knapsack, so a given capacity, and so you have to choose the number of items that will optimize the value, since each item is assigned a given weight and value. So one application this is used in every day now is daily fantasy sports. So essentially people have developed algorithms that optimize their weight and value in terms of fantasy football. So in terms of the performing athletes, which are the items, their salary or cost, which is their weight, and then the value, so the fantasy points scored. Again, this is used in many sports through daily fantasy. Basketball, football, golf, MMA. Football will be the sport we'll be focusing on in this presentation. So daily fantasy is growing in sports, and one of the reasons of its popularity is the ability to choose a new team, if not multiple teams per week. Unlike regular fantasy, where you draft a team at the beginning of the season and have to deal with those players and their injuries and whatnot. Daily fantasy sports gives you a chance to win a tournament every week. And so the scoring is pretty similar. Each player is allotted points per reception, yards, touchdowns, etc. There are three main website organizations: Yahoo, DraftKings, and FanDuel. All pretty similar with their slight tweaks and adjustments. DraftKings is what we will be focusing on for this presentation. So developing an algorithm. So according to the rules of DraftKings in fantasy football, a person is to draft one quarterback, two running backs, three wide receivers, one tight end, one defensive special teams, and then a flex position, which is an additional running back, wide receiver, or tight end. So essentially, what we're looking for is the best points per dollar spread. In analyzing these players, we're looking at basically the floors and ceilings of each player, because that's going to play an important role in how to achieve the optimum score in these games. So for instance, a cash game is where the top half of entrants double their entry fee. And essentially here they're looking for steady performing players of low volatility, and then and just a high average score. And essentially we want this because since the top half of entrants cash in this, it doesn't matter if we beat the last person by 5 points or 500 points. So essentially we're looking for a score around 150 points in this game, which averages to about 20 to 25 points per player, which is pretty doable. Whereas in tournaments, we're looking for basically all our players have to have the best possible score imaginable. So, and this is where people put high risk players that may only get a few opportunities on the field but may have a chance to make a big play. So that's where these high risk players with very high volatility are going to come into play. And so typically, since people can draft the same players and have the exact same lineups, people are looking for those players with a low draft percentage, and so a low draft exposure, and those lineups typically win. Average scores here come out to somewhere around 200 to 300 points, so that means players average about 35 to 50 points. So in our analysis for this, we're going to be using a VBA Excel coding based statements, if-else statements, switch case, and for-while statements. We're going to import data from multiple sources and average those out to develop some sort of weighted average formula. Also, within the weighted average, we're going to do what's similar to stock analysis volatility in our players, using stats from previous years as well as the same year. Also, from there, we're going to do a little bit of Monte Carlo analysis to formulate the risk of each player within that volatility. So why is the significance of this? Well, professional gamblers typically can win up to 90% of the time using their optimizers and their algorithms. So essentially, we can just formulate our odds to win by just developing a good algorithm for this, which I think is pretty interesting considering how volatile sports can be and how unpredictable they can be, professionals have been able to do this in a controlled manner. So essentially, that's what we're going to do, and also we're going to see kind of how this relates to. It's almost similar to how stock portfolio analysis is, where professional DFS players will essentially minimize all risk by choosing max number of lineups and max number of players. So essentially, they're really just reducing risk in all their speculations using their optimizers, which is I think is pretty interesting.